Okay, welcome back. Only 1 week later. The previous films we showed you how to put the potassium silicate solution on, and then followed by a solution of lime water, and and then to let it dry. And I forgot to mention at the time, don't use any accelerated means of drying it. It should be dried slowly, and if in a particularly hot climate, a dry climate, you're probably advisable to rinse it down with some water a couple of times during the day that it's left to dry, to provide plenty of water in there, which is what forms the crystalline bond structure in this compound, which is what gives it its strength. I think that's a kind of practice that people who lay concrete and stuff in hot countries have to do to ensure a good bond strength. So don't dry it artificially. Probably not a good idea to do anything like that in air conditioning, which I've found to be detrimental to a lot of violin making processes, particularly varnishing and gluing. So don't do it in an air conditioned environment, or at least don't let it dry in an air conditioned environment. Right, so the next stage is to remove the compound of potassium hydroxide, which is formed as a sort of end product, as well as the calcium silicate which we want. We get potassium hydroxide, caustic potash, which is not too desirable. Anyway, what we do is we make a solution. We make a solution of, this is iron chloride anhydrous. We need to put a bit of that into water to make a fairly concentrated solution. There is a reason for this, why I'm using this. In the analysis of the ground layer of these old violins, there's quite a large proportion of iron being traced, and how does that iron get in there? Well, you don't put it in as bars of iron, obviously, but if you use it in a solution to wash out use iron chloride solution to wash out the potassium hydroxide, then you always get two reactions going on when you do something in chemistry. There's a result of the iron chloride and the potassium hydroxide is to form potassium chloride, which is a kind of salt, and iron hydroxide, which is rust. And so basically you wash out the caustic solution and you're leaving a rust solution on the wood, which is a sort of golden orange colour. I'll demonstrate it, I think is the best thing. And the golden orange colour, of course, is highly desirable in a old violin on the wood. It's actually eventually a cinnamon colour. There we go. Let's put plenty of this on, because by this stage your wood is waterproof, or the surface of the wood. It's not going to do any harm. Sort of fairly flood it on pretty much, and sort of drain it or dry it out afterwards. Get some of the excess out now. It's like a bit of a pooling because I've used quite a generous amount. I'm not going to dry it out as such, but I'm going to get that excess out. Make sure it's all nicely done. As I say, it's not going to be seen in there particularly, but it's a good which makes it a good place to practice, to see what the effects of this treatment is. If you do it on the inside first, do the same on the belly. Doesn't prevent gluing if you get it on the gluing surface, I don't think. Just repeat, the analysis of the wood has shown large amount of iron, but it's not elemental iron, it's iron in a compound, and this is my interpretation of how it got there. It's got slightly acidic reaction, the iron chloride, and it reacts with the potassium hydroxide to wash it out of the wood and convert it into harmless potassium chloride, which hopefully will get rid of most of that as well in this process by drying it out. If you'd used sodium silicate instead of potassium silicate, you'd be getting the same reaction results, but you'd have with potassium, we're going to have potassium chloride in small amounts. With sodium hydroxide, you've got sodium chloride, salt, which has also been found to be present in the wood. So depending which silicate you were using, I guess, on the source of your silicate. There's also a large presence of aluminium in the ground, which possibly comes from the use of naturally occurring pozzolana cement or whatever, which we haven't got in this, because basically the calcium and aluminium will work in the same way, but you might want to, or somebody might want to try some other method of in the same way. Right, I think that's it until that dries now. That's all it requires, and then glue that up and finish on the outside by doing exactly the same thing that we've done on the inside. Right, we'll have a look at it when it's dried and see how that compares with what we started out with, I guess. Okay, that's it. Right there.